Hi all, today we are going to see about the link aggregation control protocol. This protocol is also named as LACP. So we are aggregating two or more links into a single link in order to have improved bandwidth and to have redundancy and to also the cost effective way of effectively using the network. Okay, so these are the three things. One is improved bandwidth, cost-effective way of increasing the of using the network, and the third thing is redundancy. Redundancy is if one link fails, the other link can take over for the traffic. If you associate this LACP link into any traffic, okay. So this will be these are the two switches, and you have two links between them, and they are aggregated to form a LACP. Okay, before that, let's get into some important tips. See, this LACP, for LACP to come up, we need system ID. Okay, system ID is a 48-bit ID, unique for each system. Okay, LACP can be formed between two systems only. So, the system ID should be unique for both the systems. So, usually it is the MAC address. Okay, then we have the system priority, which is a 16-bit value, key ID, key priority, which is also a 16-bit value. Then, okay, these are the things. So, system ID should be unique. And what are the other parameters is, see, in LACP, we will put on the links into the lag, right? We will associate the individual ports into the lag. So, these port characteristics should remain the same when they are associated inside a lag. What are the port characteristics? Namely, speed, negotiation, MTU, or any QoS configurations or anything which is present over the port. These things should be common across the links which are present, which are to be associated inside the lag. So the first is system ID should be unique. No two systems can have the same system ID. Okay. The second is the port related characteristics of the links associated in the lag should remain the same. Okay. Only the similar kind of ports can be aggregated to form an LACP. So these are the 2 points. So please remember in mind. Then to talk about the flags. Okay, whenever you have two links aggregated, okay, and you start LACP, so these are some of the flags which will be traversed for the LACP to come up. The first flag is activity. Activity is like LACP is active or passive. So generally in network protocols, there are two modes. For any protocol, there are two modes. One is active mode and the other is passive mode. Okay, active mode is a mode where the system will send out a particular packet, protocol packet. Okay, passive mode is a mode in which the system will wait for the packet, and then upon reception of the packet, this will transmit the packet. Okay, this is the passive mode. So no two systems can be in passive mode. Okay, either active passive will work or active active will work. Passive passive will never work because both the systems will be waiting for the packet to be received. Okay. Next is timeout. Timeout is the rate in which the packets are transmitted. It can be fast or slow. Fast in the sense every 1 second interval. Okay, it all depends upon the implementation. Okay, and slow in the sense every 60 seconds. Then you have aggregate. Aggregate is like whether the links can be aggregatable or not. That is what aggregates. So, see, for example, some links cannot be aggregated, cannot be combined into a single link. So in that case, the links can be aggregated or not. The next is synchronization. Whether the LACP is synchronized in the sense whether the LACP is fully functionally up. Okay, that is the flag which indicates the synchronization. Then collecting and distributing is like collecting corresponds to reception of the packets and distributing corresponds to transmission of the packets. These two things should be true for any traffic to flow. Okay, then expired state comes when you don't receive the packets for 3 intervals, and defaulted state comes when you don't receive the packet for 6 intervals. That's it about the flags. So we'll summarize again the activity: timeout, aggregate, synchronization, collecting, distributing, expired, and defaulted. These are the flags. Okay, let's go on to the PPT again. What I had explained before. Okay, this is the flow chart for a LACP. So we have the start. Then first all these flags will be cleared. Then it will check is the link a member of the active subgroup. Okay, if it is yes, does the remote system ID and key match our own? Okay, if it is going to be yes, remote system ID should never match our own system ID because it should be unique. If it is matched, then there is some looping. Okay, then we should check our connections. That is our port is mapped to our system itself. So there is the kind of looping here. If it does not match, if they are going to be unique, then it will check whether does the remote, that is the peer, advertise our system ID as the partner. So the peer should always, when we send a packet in all the network protocols, the peer should recognize our packet and should send an indication to us saying that I have recognized you. So the indication factor is here the system ID of our own. So the peer will send our system ID as a partner. Okay. So if that is yes, then it will check whether the remote system ID and key consistent with other links in the lag. So if there are two links, all the two links should be under the same system ID and should also be under the same key. So that should match. So if that is also yes, then the sync flag will be set. Then in the partner also the sync flag will be set. If both the sync flags are set, then it will set the collecting and distributing flags, and that's it. Your LACP will become up. If in any case where there is any problem, if there is unidirectional link failure is one side the traffic will flow, the other side will not be able to receive. So in that case, your LACP will be down. Or if there is a cabling fault, your LACP will be down. Or if there is any configuration error also, your LACP will become down. So this is the flow chart which explains what is the process which is going in LACP, working condition and non-working conditions. Okay, so the next is this is one of the error scenarios where the system A has one system ID, okay, and system B and C, the links are aggregated with respect to two different systems. In this case, system B will have one system ID and system C will have one system ID. So if this B and C send the packets to A, the A will recognize that as like the two packets are coming from two different systems, and an LACP will not be formed. Okay, this is one of the error condition. And the other condition is, see, in this case, both are unique systems. System A and B are unique. But if you see here, lag 1 from system A is from the same lag. But in system B, one link is from lag 1 and the other link is from lag 2. So if there are two different lags, then there will be two different key IDs. So when there is a mismatch in key IDs also, the LACP will not be formed because in a particular lag, the key IDs should be unique across a system. If it comes from system B, then then the two links which are in the particular lag should have the same key. If there is a key mismatch, then the system ID is matching, but the one of the links corresponds to a different lag in the peer system. It is like that. Okay, so this is one of the error condition, and the other error condition is you have a single system and both the links are looped back to the same system. In that case, also the system ID will be unique, and the LACP will not be formed. Okay, and the last condition is unidirectional failure. Unidirectional failure is the peer system can receive the packets, but when it sends the packets, we will not be able to receive it. That is one kind of error condition, unidirectional link failure. In that case, also LACP will not be formed. Okay, this is somewhat basics of LACP. So people who are not aware of what is LACP, it will be a good start if they go through this video. So some of the simple questions you could answer after watching this video. So what is the status of the port channel if LACP is misconfigured? So A, forwarding; B, enabled; C, disabled; D, error disabled. So forwarding enabled, it will not happen because LACP is not configured properly. Due to misconfiguration, your LACP will never come up. So it should be disabled. C is the correct answer. The next is, what are the benefits of LACP? A is increased bandwidth. B, automatic occurrence of failover and fallback. Cost effective method. Less drain on the network address pool. All of the above. So all these conditions apply. Bandwidth was also increased. There is a failover and fallback. No, it is not failback, it is fallback. And it is also a cost effective method, and less drain on the network address pool, because less drain in the sense you need not have separate interfaces. Okay, the two interfaces can be under the same lag, and you can have a single interface because they are aggregated into a single link. So the answer is all of the above. The third is, what are the flags of LACP? First is active, second is standby, third is master, fourth is sync. Sync is the flag. We have seen some flags, right? So sync is the flag. So that's it, guys. Thanks for watching the video. Stay tuned for more videos. And please don't forget to subscribe my channel. Thank you.